Hi, we're going to spend the next few minutes talking about what your second grade student in College Station ISD will be doing in math during the first 9 weeks. This is actually part one for the first 9 weeks in second grade. So after you watch this, you might want to go find part two and part three so you can get the whole picture of what your child will be doing in second grade math for the first 9 weeks. So here's an overview. Part one, we're going to talk about solving addition and subtraction problems up to 20 because that's where they left off in first grade. And so that's where we're going to pick up in second grade. Part two talks about using attributes to classify 2D shapes and 3D solids and to review what they learned about telling time in first grade. And then part three talks about using non-standard algorithms to solve one-step problems with up to two-digit numbers. So here at the beginning of the year, we're working on addition and subtraction within 20. We're going to get to larger numbers, but we're going to start off within 20. So we can talk about processes and focus on learning the concepts without having to worry about such large numbers. And then as we develop those concepts, then we will start bringing in larger numbers. So they worked on learning basic facts in first grade, but the goal is by the end of second grade that they really should be able to recall the answers to addition and subtraction basic facts with automaticity. That means very quickly without having to spend a huge amount of time thinking about it. And so in order to encourage that thinking, we're not just giving them the whole addition chart and saying memorize it. We break it apart into strategies. And so maybe they'll start off with working the addition and subtraction of 0. And once they can recall that very quickly and it had developed some automaticity with that, then they may move on and work on addition and subtraction of 1. 6 plus 1, 8 plus 1, 9 minus 1, 1 plus 4. And then maybe to move on to plus or minus 2. Then work on doubles. For instance, 4 plus 4 is 8, or 6 plus 6 is 12, or 14 minus 7 is 7. So we're doing addition and subtraction. And then combinations that make 10. I need to know that 4 and 6 go together to make 10, 1 and 9 go together to make 10, 2 and 8, 10 and 0, all those combinations. The combinations that make 10 are really a fundamental building block for kids to be successful when they start adding multi-digit numbers, adding together 2 and 3-digit numbers and subtracting 2 and 3-digit numbers. So we really want to make sure that they know those combinations that make 10 really well. And once they know those combinations that make 10, they can extend that to help them with these addition and subtraction of larger numbers. For instance, if I know that 4 and 6 make 10, then I know that 14 and 6 make 20. Because that 14 has a 10 in it. So then I can take that 4 and put it with a 6 and make another 10. And so those two 10s go together to make 20. If I know that 5 and 5 make 10, then I know that 15 and 5 make 20. Because I can take the 10 out of the 15 and then put those two 5s together and make another 10. And those two 10s go together to make 20. So once we know the basic combinations, 4 and 6, 7 and 3, 10 and 0, then we extend it into the teen numbers. 14 and 6, 12 and 8, 18 and 2, and then we can start extending it into any number. If I know that 7 and 3 make 10, then I know 47 and 3 make 50. And if I know that 1 and 9 make 10, then I know 61 and 9 make 70. So we're building, we start off and we just keep building and building on it so that we have that good number sense and have these strategies to call up when we're trying to work with larger numbers and we're developing good strategies for mental math. Another skill that they really need to help them be successful with multi-digit addition and subtraction is to be able to count by tens off the decade numbers. They should already know 10, 20, 30, 40, that's counting on the decade numbers. Now, if they start with 33, they should be able to count 33, 43, 53, 63, and so on. And we want to make sure that they're also crossing over 146, 56, 66, 76, 86, 96, 106, 116, and so on. We also want them to be able to count by 10 on off decade numbers backwards. 91, 81, 71, 61, so on. 175, 165, 155, 145. So knowing how to do that is going to give them another tool in their tool belt when they're trying to work with larger numbers later. They also need to be able to locate the position of a given whole number on an open number line. And these are examples of open number lines. An open number line can have just a few numbers on it, a few benchmark numbers, or it can have no numbers on it, and then you just put the numbers on the number line that you need to solve whatever problem you're dealing with. So right now, we're just kind of developing number sense. So if I asked a student to put 48 on this number line, they would want to put it down here close to 50. If they put it down here next to 40, then we would need to talk about, you know, when I count from 40 to 50, do I say 48 closer to 50 or do I say it closer to 40? You know, if I asked them to put 51 on here, you know, it should be right next to the 50, you know, between 50 and 60. We also want them to be able to determine whether a number up to 40 is even or odd using pairings of objects to represent the number. So it is really not about just memorizing that numbers that end in 0, 2, 4, 6, 8 are even, and that numbers that end in 1, 3, 5, 7, and 9 are odd. It's really about developing the concept of why we say a particular number is even and why we say a particular number is odd. They may generalize what they learn and eventually come up with the rule of which numbers are even and which numbers are odd without having to do the pairings. That's our goal. But we're starting out building that concept. So if we look at this 10 frame, and it's a 10 frame because there are 2 rows of 5s for a total of 10 boxes. And there's a dot in every box. And now in the standard, it says using pairings of objects. So if I pair these 2 dots and these 2 and these 2 and these 2 and these 2, every single dot can be part of a pair. So 10 is even because every dot object has a partner, it has a pair. 9 is odd because I start pairing these 9 dots and then there's 1 left over that doesn't have a partner to pair with. So this one's the odd man out. So that's why 9 is odd, because when I pair items in a set of 9, I have 1 left over that does not have a partner. And so we're working just up to 40 on that because we don't want to give them a ridiculous number of things to have to pair up. But we're working up to 40 and using objects so that they can begin to understand why this is even and why another number is odd. They also need to be able to generate a number that is greater than or less than a given whole number. Right now, we're only working up to 120. By the end of the year, they will be doing this up to 1,200. So we're starting up to 120, and then we'll build up gradually. And for instance, we could say, tell me a number that is greater than 52. And it could be 53, it could be 99, it could be 1,000. Any number that is greater than 52 is a correct answer. Tell me a number that is less than 88. It could be 87, that's 1 less, or it could be 1. That's a lot more farther down the number line, a lot less than 88. So we're working right now within 120 doing this, and then we'll gradually build up. They're also going to be solving one-step word problems involving addition and subtraction within 20 using a variety of strategies based on place value, including algorithms. So I want to talk about a few parts of this. Right now, we're just doing one-step word problems. Later in 2nd grade, we will be working on 2-step word problems, and we're sticking to addition and subtraction within 20. So again, we're keeping the numbers simple so that we can deal with concepts and ideas and strategies. And then once we've really got those down, then we can start expanding the range of number, working with larger numbers. And we're going to be using a variety of strategies, you know, a lot of them based on place value, including algorithms. And so I want to talk about the word algorithm. An algorithm is just a method. And so, you know, when we were in school, we were all taught what we call the standard algorithm, which is just the way that most of us solve addition and subtraction. And that's one way to solve those problems. And we are certainly not going to ignore that. They're going to get there. But we want to build concepts with them by exploring lots of different algorithms. And we call them non-standard, just to differentiate them from the standard algorithm that we're used to. And so we're going to talk about a lot of different ways to solve these problems, to develop number sense, to develop more facility with these numbers, and a lot of mental math strategies. Not that we're not going to get to the standard algorithm. We're just going to play around with other strategies first. They're also going to generate and solve problem situations for a given mathematical number sense involving addition and subtraction of whole numbers within 20. So this is for a given mathematical number sentence. So if I said, please create a word problem that could be solved with 5 plus 6, then they need to create their own word problem. It could be Mary had 5 apples. She went to the store and bought 6 more. How many apples does she have now? So they created a word problem that matches the expression or the number sentence that they were given. And then they need to solve the word problem. They need to say, well, 5 plus 6 equals 11. So she has 11 apples now. And again, we're sticking within 20 for now, but we will be moving to larger numbers. They also need to represent and solve addition and subtraction word problems where unknowns may be any one of the terms in the problem. And so in part 3 of this first 9 weeks, you'll see several different representations that they can use for addition and subtraction, and the open number line, part whole models, pictures, lots of different representations. And the unknown may be any one of the terms. So it could be 8 plus question mark equals 13, or it could be 8 plus 5 equals question mark, or it could be question mark plus 5 equals 13. So the unknown could be any one of the terms there. So if you go to the CSISD website and you click on curriculum and then click on math and parents, then there's a section called resources. And if you look in there, you will see lots of different topics. And if you click on the topic that you want your child to practice, it will pop up with several different websites that you could go to give your students good practice with that particular topic. When you look at the topics, one of them is word problems. And in there, you will find a website called Thinking Blocks. And right now, you probably want to go to Thinking Blocks Junior, because you can restrict the numbers to within 20. But that's a fabulous site for solving and modeling word problems. So I highly suggest that you go to Thinking Blocks Junior and start practicing with your student. So thank you for listening. There's going to be a new series of videos at the beginning of each 9 weeks to talk about what's coming up in math. And if you watch these and you still have questions or just want to discuss something, feel free to contact your child's math teacher or the math specialist on your campus. If you go to this website, there's a list of all the math websites and math specialists in the district. And so you can find the name of the math specialist for your particular campus and contact her through email or the phone call if you have a question, as well as your child's teacher. Again, thank you for listening, and have fun learning math with your child.